Morning. My name is Stephen Cooke, and I'm a professor at Carleton University in Ottawa, and I study fish. I've been a long-time user of Queen's University Biological Station, and in fact, much of the research that I'm going to talk about today is based on research that we've done there. I'm very much a passionate scientist, but I'm also a passionate angler. And so that's one of the themes that you'll see throughout today's presentation. I really love what I do. In many ways, this science feels like a hobby. It's a perfect way for me to meld my deep interests with fishing with my career, which is as an educator and a scientist. So today, my presentation is titled The Science of Catching and Releasing Fish. So this is something that I spend a lot of time thinking about. As somebody that knows a fair amount about fish, I should be able to use that to my advantage to help catch more of them, to catch bigger fish, and so on. And we'll talk about that. We'll see whether or not that's true, whether there's any validity to that. And then I want to move on after that and talk about what happens to the fish that we release. The majority of the fish in Canada that we catch are actually returned back to the water to swim. They swim away. So what happens to those fish? Do they live? How do they do in the long term? And what can we as anglers do when we're interacting with those fish, ensure that they have a strong likelihood of surviving and doing well? A little bit about me. I've already mentioned that I'm super big into angling. For me, it all started when I inherited a tackle box from my grandpa when I was about 7 years old. I spent my days in school dreaming about being a professional angler. People like Bob Azumi were certainly strong influences in my life, watching them every Saturday morning on TV. And then at some point, I realized, hey, maybe I should do some schooling as well. And it was at school that I started to, in university, that I started to realize that I could study fish for a career, that I could be a fisheries manager or a fisheries researcher. And that's essentially what I did. And in 2005, I joined the professoriate, came to Carleton University, and now our team does research in the space of recreational fisheries science. And so sort of closing the loop there. So kind of fun. In terms of context, maybe we should start off, first of all, with what is recreational fishing. And I think it might sound silly. Why do we need a definition? But there's a couple of things that are interesting here. So, first of all, it's fishing of aquatic animals. Note that it doesn't say anything about fish specifically, aquatic animals that do not constitute the individual's primary resource to meet their nutritional needs. So, in other words, you aren't going fishing as your only means of obtaining nutrition and food, and that the fish that we catch when we go fishing are generally not sold or otherwise traded on international, domestic, or black markets. So, in other words, we don't sell those fish or trade them. Notice there's no mention of rod and reel, and in fact, if you look at the bottom here, I'm showing there's a nice salmonid that's been caught by rod and reel, but in the middle there's a picture of somebody bow fishing, and then off to the right there's a picture of somebody that's spear fishing recreationally. All of these are forms of recreational fishing. It's only when we say recreational angling that we truly mean with hook and line. There are lots of benefits to recreational angling, and that's what I'm going to talk about today. By the way, I'm not going to delve into other gear types. I'm going to talk about rod and reel, but they're many and they're vast. So certainly there's the economic side of things. In Canada alone, between $7 and $8 billion a year we spend on recreational fishing. That's more than twice the value of the commercial sector in Canada, and I think that's something that tends to blow people's minds. There's, of course, the social bonding, spending time with friends and family. There's a quality of life aspect to spending time outdoors, reduces stress and negative emotions. There's even evidence of reduced crime propensity in young people. You may be familiar with the old program back in the 80s, Hooked on Fishing, Not Drugs, as a good example. People that are connected with nature, with fish and wildlife, tend to become more educated about that and advocates for that, and that creates empowered citizens that make good decisions, hopefully, with respect to how they vote and how they consume or otherwise interact with the environment. And then finally, recreational angled fish are an excellent local organic food source. And as noted before, not the primary food source. It's presumably not the only thing you're eating, but it certainly can supplement what we purchase from stores and grow in our gardens and so on. So how many fish do we catch? Well, Canada, through Fisheries and Oceans Canada, does one of the best national surveys that gives us an idea of what we catch and what we release and how many people do it. We do this survey every 5 years. And if you take those Canadian numbers and simply scale them up to how many people there are in the globe, and we do that simply because we don't have the data from elsewhere. Canada is one of the few jurisdictions that does this. It suggests that global recreational capture rates may be as high as 47 billion animals. If we use the Canadian release rates, which are approaching 70% now, there's as many as 30 billion of those fish that are potentially released, returned to swim again. And of course, there's lots of variation depending on where you are in the world with respect to how many people actually engage in this activity and how many fish are released. The point is, you can knock a zero off these numbers. It doesn't matter. The point is there's a ton of fish that we catch and there's a ton that we release. And that's why I'm so fascinated in this science of catch and release. So my outline today, as I mentioned, I'm going to hit on two things. I'm going to talk about what can science tell us to help us catch more fish or bigger fish. And then I also want to spend a few minutes talking about what we can do to ensure that the fish we do catch are released. So let's start with that first question. So one of the things that I'm often asked are, do Lunar tables work? These are the things you find in the back of fishing magazines or online. You can even buy devices that'll tell you when are the best times and days to go fishing. And the question is, do they work? One of the best studies that's been done on this was done in Minnesota or Wisconsin, can't remember which, that part of the Midwest. And essentially, they analyzed catch rates for over 340,000 muskellunge to see whether there was a lunar effect. They did find that the number of fish caught was related to that lunar cycle, with more caught around the full and new moon. But I think this is the really important point. Yes, it was different, but the effect was very small. On average, on those peak fishing days, you caught 5% more fish. When we're talking about muskellunge, that's a very, very tiny difference. If you go out and catch one muskellunge every 3 to 5 outings, we're talking about 0.0001 extra fish that you're gonna catch potentially on those good fishing days. So something that's certainly not going to send me running to fish just because a Lunar table tells me to do so. We've done some of our own research right here at Queen's University Biological Station using one of our research lakes. So this is a lake that we had outfitted with a 3-dimensional telemetry array. So we knew where these fish were 24 hours a day, 7 days a week. And you can see on the screen there, that trace in the lake, those blue lines you see looping around, that's one fish over a 24-hour period. So we know exactly where they are. We can go to a computer screen in a little hut that we have beside the lake, and it'll tell us where we should be fishing. And so we were able to position these fish within 1 sort of cubic meter of space, and we did this over 5 years. And we evaluated movement and depth distribution to see whether lunar phase had any influence on catch rates. And it turns out on catch rates, on their behavior in general. And the only thing we saw was that in the spring, so in one season, on waxing and waning phases, we saw that the fish were in slightly shallower water. And if you're fishing for largemouth bass, shallow water might mean that they'd be easier to catch. That is it, and that is, a very tenuous link. So I would submit that Lunar tables are not overly helpful in informing when and how we should fish. If you've got time to go fishing, do it. What else can we learn from that lake, that 3D telemetry array that I just showed you? So a couple things that I find interesting. First of all, this is only a 10-hectare lake. Based on some of the work that we've done, we estimate that there's about 600 adult bass, so fish in there that are about 10 inches or larger. And we still go fishing on that lake. And a reminder, this is a private research lake. Nobody else fishes there. We still have days where we go out and catch none of those fish. And what's particularly remarkable is we do that when we know exactly where they are, within 1 cubic meter. We go out there, and despite knowing where they are, we can't catch them. It doesn't matter whether you throw live bait at them, lures at them. There are simply some days, sometimes, when the fish won't bite, even if you know whether they are. So this is a $500,000 telemetry array, and it's still not enough to guarantee that we catch fish every time we go out. So I think that's really quite telling. One of the other things we've done is say, well, what does the broader literature tell us? When we look through all of the science that's been done on the vulnerability of fish to capture by hook and line, what can we learn from that? So Robert Lennox decided to tackle that question, and so he amassed a database of over 300 papers that looked at whether or not fish, what makes a fish catchable, essentially. And there were two things that popped out. So first of all, and not surprisingly, when a fish is hungry, it increases the probability of them being vulnerable to capture. Common sense, right? The other thing is that encounter is a necessary yet often insufficient aspect or condition for capture to occur. So in other words, you actually have to put your lure near the animal that you're trying to catch. If you fail to do so, it's impossible to catch that animal or any other animal. However, just because you do that, just because you put a lure or bait near a fish, doesn't mean you're going to catch it. Okay? So remember, 300 papers, thousands of hours of work here by Rob and our team, and that's what we conclude. Fish have to be hungry, and your lure needs to be near them, and then maybe you will catch them. We took all of the information that we learned from that review and created this schematic that you can see here. And there's a lot of things that feed into this, but at the end of the day, there was nothing that came out as being particularly important. Obviously, fish need to sense and be able to respond to that lure or bait. They need to see it or smell it or feel the vibrations. They need to be able to move to encounter it. They need to be hungry and so on. So there's a lot of things that influence vulnerability, but at the end of the day, there's not much we can take away from here. I was hoping that we would find the Holy Grail, and if we did, we might not even have shared it. We might have kept it a secret. But at the end of the day, we found nothing that will really help you catch more fish. So can science help you catch more fish? I think the answer is yes, but not through reading a whole pile of scientific papers. It's going to come through understanding the basic natural history and biology of these animals. How do they interact with each other? How do they interact with their environment? What are their environmental requirements? What water temperatures do they like? How much oxygen do they need? If you're fishing in areas that are outside of those norms or preferences, then you're unlikely to find those fish. Where are they in different seasons? When do they move? Where do they move? How do they eat? How do they sense their environment? Those are all things that'll help you decide what you're going to fish with, where you're going to fish, and when you're going to fish. This information is accessible in books, magazines, websites, but I would argue it comes most importantly from time on the water. The people that spend the most time on the water tend to be the best anglers, and that's because they start to pattern things. They start to learn about these things from doing. And I say not on the water, but also in the water. And so there's a picture of me with a mask and snorkel on. I learned so much about fish by putting my face into their world. So throw on a mask and snorkel, snorkel around your favorite coastal environment or your favorite lake or river and watch what the fish do. It's a really good way to understand how they eat and how they behave, how curious they are, and so on. All right, so let's transition to the second part. The second part's a little bit longer, and it's where the science is certainly important and where we've learned quite a bit. So what can we do to ensure that released fish actually survive? So catch and release angling is something that has happens for a variety of different reasons. In some places, it's mandated, so there's regulations that require that we return fish to the water. In other places, it's voluntary. I was fishing this morning, and we caught some bass. If I wanted to, the season is open, I could have harvested those bass, but I decided to put them back. I didn't feel like eating bass today, wanted to see those fish grow bigger and have an opportunity to reproduce next year. In some places, catch and release is actually discouraged. Managers use regulations to try and craft fisheries to be what we want, what the public wants. So sometimes we want a trophy fishery, and that might mean harvesting certain sizes of fish. So in some cases, catch and release is actually discouraged. We want people to harvest fish of certain sizes or species. And then I've got the word verboten. Verboten is forbidden in the word German, and that's because there's certain parts of the world, including Germany, where catch and release is frowned upon, where in fact there's legal constructs that require people to keep fish associated usually with animal welfare legislation. So that's something we're not going to delve into today. It's another fascinating topic to consider, but it's something I wanted you to be aware of. Now, a lot of people think catch and release is new, that this is some new age activity. In fact, we can go back to the 1400s and find individuals, in particular Dame Juliana Burns, who was arguing for conservative harvest to protect the resource and encouraging people to put fish back, including the big ones. Although it really wasn't until the 1500s that we started to see fishing regulations come into place in the UK and France, and many of those regulations were based on releasing certain species or certain sizes of fish. So catch and release is not new, even though we like to pretend it is. It's something we've been doing for really quite some time. Now, catch and release rates are highly variable. On the left there, I've got trophy muskie, and on the bottom, a bonefish. I'm going to guess that across the board, somewhere 95, 99% of those species, of those fish, of those two species, are released when they're caught. On the other hand, in the top panel there, those are walleye in the fry pan, and there's an Atlantic cod below. They have high harvest rates. They're particularly good in the frying pan. People like to eat them, and so harvest is accordingly high. So it tends to be the more specialized fisheries like bonefish and muskellunge where we see really high release rates. But in general, it tends to vary. From the moment that we interact with a fish when we're fishing, so they come along and maybe give our lure a sniff, to the point where we hook it, fight it, handle it, release it. There's a lot of things that can go on. And I don't expect you to take much away from this table other than to realize there's a lot that influences what happens to a fish when it's caught and released. And that means there's a lot that's up to us, the angler, that we can do to help ensure that it's a good outcome for those fish. So what do we know? So far, there's been over 400 studies on catch and release that cover marine and freshwater fish. Most of those focus on generating short-term mortality estimates. So scientists go out, they fish with different gear, they hold the fish for 24 hours and say how many fish live, how many fish die from different gear types. We do know that many fish are released, and we do know that some fish die. The number of fish or the percentage of fish that dies varies immensely depending on the species and the context. In general, most fish survive catch and release, but there are certain contexts where release mortality can be high. Sublethal effects are also possible. So just because a fish survives doesn't mean they're perfectly fine. Every fish that's caught with rod and reel is injured. They have to be. You've used a hook to catch them. Similarly, they're going to be experiencing some level of stress. They're unsure what's happening. They've had to fight. You're handling them. That causes a stress response. So injury and stress just happen. They're a given with fishing. And so our goal is to try and minimize those things so that we don't see any impacts on growth, health, survival, reproduction, and so on. There are a lot of things that influence whether or not a fish will survive a catch and release event. Everything from the biology of the fish, the size, the species, even the sex matters. Some of the work that we've been doing in British Columbia on sockeye salmon shows that females tend to do far more poorly when exposed to catch and release relative to male sockeye salmon. Environment matters. Water temperature is huge. We'll talk about that later. Depth. Whether fish are caught at depth where they might experience barrow trauma, or the number of predators around. Our behavior as anglers also matters, how long we air expose a fish and how we handle it. Our gear choices, hook type, line strength, and of course, angler experience and knowledge all matter. A lot of people think that catch and release science is also new, yet it is not. The first study that I'm aware of on catch and release science was done way back in the 1930s, which focused on trout in Michigan. If we look at all the science that's been done, there's a single thing that pops out as being the most important driver of whether or not a fish survives a catch and release event, and that is where the fish is hooked. It's all about deep hooking. So, shallow hooking being caught in the lip or jaw region, deep hooking being in the back of the throat, or what some people would call the gullet. And you can see there a picture of a fish that's been injured, and there's some bleeding back in the gill region and in the gullet itself. So the best option then is to minimize deep hooking. So what influences deep hooking? Here are a couple trends from the literature. And there's a lot of science to back up each of these. I'm just summarizing it here. So first of all, bait and lure type matter. We know that organic baits, so live bait or dead organic bait, so everything from corn to minnows and so on, they tend to be ingested more deeply than artificial lures. And that's not surprising because those are actually food items that those fish could consume. Bait and lure size matter as well, and a lot of people think that bigger lures, oftentimes have more hooks, do more injury, but it's actually smaller lures that are easier for fish to get in their mouth and get taken more deeply, and that can lead to mortality. The fishing style or method matters as well. Passive fishing leads to much deeper hooking than more active fishing. So passive fishing would be sitting there with a worm on a bobber, kicking back and sort of only half paying attention, whereas active fishing would be trolling or reeling in a lure in real time. So when you're fishing passively, it just gives the fish more opportunity to actually start to consume that bait. Experience matters. If you've ever gone fishing with kids, you know that there's a lot of deep hooking that occurs. So basically, novice anglers tend to yield deeper hooking, whereas more experienced anglers are able to detect that bite and set the hook more quickly. And then hook type and style matter. We know that conventional J style hooks, so hooks that look like the letter J, tend to be taken deeper relative to something that's called a circle hook. And so our circle hook's the answer. So what is a circle? A circle hook. So I've got one on the screen here. You can see, unlike a J hook, which is sort of a normal sized fish hook, if you ask somebody to draw a fish hook, they draw a letter J. A circle hook is different. The You can see that the point of the hook, instead of being parallel to the shank, is actually perpendicular. And so it's sort of a round or circular configuration. And so what happens is those hooks, when they're taken more deeply into a fish, say into the gullet area, when that hook is pulled out, unlike a J hook, which would get stuck in there, this circle hook comes out and it wraps around the jaw. So on average, we see pretty substantial reductions in deep hooking when we switch to circle hooks relative to conventional hooks. In this image, this graph, you can see hooking mortality percentage for circle hooks and conventional for studies where they've been compared. And on average, there's a 50% reduction in hooking mortality when circle hooks are used across this synthesis of 24 studies. So something to think about if you're fishing with live bait. If you're fishing with lures and other things, it's less important. They've certainly been really important in the billfish world, where a lot of live bait is used, and in fact, organizations like the Billfish Foundation have pushed for these to be required in a lot of the tournaments in many regions of the world. Some people even use them for fishing with live bait for muskellunge. So lots of options out there. So something to play with. These are finally available in freshwater stores. It used to be that you had to go to a marine fishing store to find circle hooks, but now you can find them at more or less any fishing store around. All right, so another common question that I get asked is, what do we do with deeply hooked fish? So sometimes, no matter what you do, you're going to end up with fish that are deeply hooked. It happens. So are you better to remove the hook or to cut the line? There's been a fair amount of research on this now. We've done some work at Queen's Biology Station using bluegill. And what we found here, and so you can look at this little table here where you've got 2-day mortality and 10-day mortality. So our control fish were fish that were just hooked in the jaw. You can see after 2 days, all of those fish were alive, and after 10 days, only 2.5% of them died. So a couple of fish. So not a big deal. Pretty high survival rate. If we look at the line cut fish, these are fish where the hook is in their gullet, and we cut the line. We see that mortality is 7.5% after day 2, and then it doubles or so by day 10. But the worst outcome are for those fish where you actually try and remove the hook. 32% of them dead after 2 days, 44% after 10 days. So one of the big drivers here is the anatomy of the fish. So next time you're filleting a fish, look at what is near the gullet, and you'll see that the heart is right there, and so is the liver. Those are two vital organisms, or organs, not organisms, to a fish. And so when a hook is in the gullet, it can cause a lot of injury when you fish around in there trying to remove it. If that hook is in there, it's kind of like leaving a plug in a dam. It prevents bleeding from occurring, and it gives an opportunity for the tissue around there to heal. It turns out that fish are pretty good at expelling these things. So 42% of the line cut fish where we left hooks in place were actually able to expel those hooks after 2 days. So and this isn't hooks rusting out. Everybody's using super fancy hooks that take a long time to rust out. So these, it's not that these hooks are rusting out per se, but the fish are able to slowly work them out. So next time you've got a deeply hooked fish, it's far better off to cut the line and let that fish go than trying to remove it. All right, what about barbless hooks? Now this one is really interesting because it's an example of where the science does not match the regulations in most instances. So mortality rates for barbed and barbless hooks vary widely, and research to date is equivocal, meaning that it really doesn't make a difference. If we look at a really great study that was done in the Gulf of Mexico, where they looked at a bunch of different species, no effect of barbless hooks on mortality. A meta-analysis, another big review of stream salmonids, things like brook trout and brown trout, no significant difference in mortality. So, a lot of people then say, well, why do these regulations exist? I think they're in place because it makes people feel good. It's the assumption that if you use a barbless hook, that you're doing something better for the fish. That said, I do use barbless hooks quite a bit. And the reason is because it does reduce injury and handling time. And although we haven't seen that transition into mortality benefits and reductions in mortality for most species, it's still a good thing to do. So for sensitive fish species, certainly things like trout, I almost always fish with barbless hooks. All right, so this is an interesting one. Yes, that is somebody pouring a carbonated beverage in the mouth of a brown trout. The idea being, and there's a lot of lore out there, that when a fish is bleeding, and as I mentioned before, fish get deeply hooked and bleeding occurs, there's this idea that you can pour a carbonated beverage over the gills, over the bloody area, and it will stop the bleeding. So after seeing this in the media for, and angler chat boards for the last 10 years, and with some prodding from some local anglers, support from Muskies Canada, and other groups, we decided to actually do some science on this. And Alexandria Trahan, the student that's lead here, has just worked these data up. We did a study on Lake Appinicon using pike as a model. We intentionally injured those animals by removing a small amount of gill tissue. And then we poured different beverages, Coca-Cola, Mountain Dew, even carbonated some lake water. You can see there us using a soda stream in the field. And we asked, does this reduce bleeding? And the answer is, it did not. We found no benefit, no evidence of benefit arising from the use of these carbonated beverages. So, but there was something that we did learn that was really quite fascinating. And we think we know why people think this works, why anglers say, oh, this stops the bleeding. And it has to do with how fish respond to having this carbonated beverage poured over their gills, particularly when they're exposed to air. And what happens is that fish go into something called a bradycardia, which is a fancy word for basically saying their heart stops for a little bit. And that's not necessarily a bad thing. That's part of their stress response. But for us, it's confusing because if you put that fish back, when that fish's heart stops, it's not pumping out blood. So for 30 seconds or so, it gives the illusion that they've stopped bleeding. What we did is we put the fish into white-bottomed coolers and watched them. And so after about 25, 30 seconds, you'd see a puff of blood. And that would have been that first heartbeat. And then maybe 10 seconds later, there'd be another puff of blood. And then 5 seconds later, another puff of blood. And eventually that heart would start pumping really fast again. And in doing so, it would be spurting out the blood. So I'm not saying this doesn't work on, across the board. This is the first study. We did it on pike in one lake in one system. A lot of people swear by it, so there's certainly more work to do here. But based on the only science that's been done to date, we found no evidence that this actually provides benefit. Landing nets. These are things that you see in most boats or most anglers that fish for shore. There's lots of different mesh types out there. Some of the work that we've done using brook trout and bluegill shows that the mesh type does matter. The meshes that are better for fish are the ones that are smoother. So you can see things like that rubber net or that knotless nylon net. Things like those polypropylene nets, they tend to cause a fair amount of fraying in the fish. And sometimes, depending on the mesh type, the lures and the hook can actually get tangled in there, and that can prolong air exposure. So I certainly don't mind using rubber nets. That's what we use in our lab for most of our research. But really reserve the use of nets where it's really essential, where you're trying to control the fish, both for your safety and for the safety of the fish. Realizing that if you can land a fish safely by hand with wet hands, that's oftentimes better than using a net. What about lip gripping devices? These are things that we tend not to use in our lab. One of the studies that we've done focused on this type of lip gripping device on bonefish. After some evidence, anecdotes that there were injuries occurring. And sure enough, you can see here some of the punctures, tears, and actual breakages in tissue and bones that occur when using these devices. This happens to be on bonefish. Some species it works all right, but this is something that there's a lot of potential for injury here. So I still prefer wet hands and a good firm grip. All right, I mentioned earlier that water temperature is a big driver. For fish, we call water temperature the master factor. It influences everything. Their metabolic rate, how often they need to eat, how quickly they digest their food, how fast they can swim, and it goes on and on and on. So across the board, what we know is that as water temperatures warm up, it gets harder for fish to deal with the stress of catch and release. Where things go bad varies from species to species. So for something like Atlantic salmon, maybe it's between 19 and 21 degrees when mortality starts to get high. Whereas for things like largemouth bass that have higher thermal tolerances, those temperatures might be as high as 28, 30 degrees before you see increases in mortality. So in general, this schematic that you can see here, you see that at low water temperatures, mortality tends to be quite low, and then it tends to increase quite dramatically past some threshold. As I said, that varies from species to species. We're starting to see lots of voluntary closures and even mandatory closures. And in the face of climate change, this is something that we'll probably see more of on those hot summer days. When water temperatures get really, really hot, those may not be the best days for fishing. Water temperature magnifies the stress that already is associated with this pastime. What about ice fishing? This is something where up until 3 or 4 years ago, we knew very little, but there's been an explosion of research in ice fishing in the last few years. Most of the work that's been done thus far shows that recovery is pretty good and survival rates are quite high as long as there isn't deep hooking. What about air exposure? So should we limit it? Here's a list of all the bad things that happen to fish during air exposure. There's always exceptions to biology, and yes, there's some air-breathing fish, but the average bass or Atlantic salmon, no time in their life find themselves exposed to air unless they interact with a human. So not surprisingly, they don't have particularly good adaptations for dealing with that type of stressor. So the gill filaments collapse, the bradycardia, that reduction in heart rate, they become hypoxic, loss of equilibrium, impaired swimming ability, and so on. So a long list of bad things that happen to fish during air exposure. So how long is too much? If you're looking for a single number that can be applied across the board, I like 10 seconds. Can you try and minimize air exposure, and try and keep it under 10 seconds. This is generalized. There are some species that are really robust to air exposure and others that are really sensitive. Some fish do become exhausted. You've caught a fish, you've reeled it in, you're trying to release it, and it looks like the fish in this picture. It's upside down. Still, it's still breathing, it's still respiring, but it needs some help. We know that its previous condition, its health and energetic state before you even caught it can be important. The species and population sensitivity varies from species to species, population to population. How long you fought the fish, environmental conditions, all of these things influence whether or not a fish will become exhausted. There are a couple things that we can do. For a long time, people assumed that it was good to push a fish backwards and forwards in the water. From a theoretical perspective, we thought in the science community that maybe that wasn't so good because fish are designed to swim usually forward, water moving in the mouth, over the gills, and out over the gills. That's how they're optimized to be able to extract the most oxygen from the water. However, some of the work that we've done recently shows that it doesn't really matter either way, whether you move them forwards or backwards or move them in a figure eight. Or if you have a big fish, say a muskellunge, if you put your trolling motor on slowly and motor the fish along, or hold the fish facing upstream into a river current, all of these things seem to be the right thing to do as opposed to letting a fish go that's floating away. But we've been as of yet, unable to resolve whether there's one thing that works better than the other. Predation is something we don't have to deal with a whole lot here in Canada, but it's something to keep in mind. We've done work in bonefish in the Caribbean and other parts of the world, and when you release a fish, or even while you're trying to land a fish, there are predators that can come along. Predators, of course, can be other fish, things like sharks or barracuda, but they can also be birds. And I think in Canada, that's probably the biggest thing that we might see. There might be some places where there's some fish that are predated by pike or muskie, but probably uncommon. But in other parts of the world, it's something that certainly needs to be considered. Barotrauma is something that we don't do a lot of work on in our lab, but I do just want to touch on it. A lot of people think that just because we fizz a fish, that we let the swim bladder deflate, that these fish are fine, that they'll go back and do just fine. There's some work that's been done on snapper in Florida that shows that there's really catastrophic physiological effects that arise from large scale decompression. So even when we recompress these fish so they can get to depth, doesn't mean that it deals with those over 70 overexpansion injuries that Jody Rummer and Wayne Bennett documented in red snapper. Obviously, red snapper are an extreme example, but just because we can get a fish back to depth doesn't mean that it's better off for it. So that's something that I think we need a lot more work on, looking at barotrauma and the long-term effects. All right, so to wrap all this up, I want to bring it together I've talked about a lot of things, but if you can remember one thing from this presentation, I want you to remember keep them wet. So I'm part of the Keep 'em Wet movement. I'm an ambassador and I'm on the board for this NGO. And the Keep 'em Wet movement is about three simple things. The first is minimizing air exposure. The second is eliminating contact with dry surfaces. And the third is reducing handling. Okay, so if you can do those three things when you're fishing, your fish will be much better off. And a lot of people, if you think about why people expose fish to air, it's because they're not prepared. They don't have the right tools at hand, whether it be the pliers or the hook cutters that you need to release a fish quickly. And people want that shot. They want that photograph. That they want to remember that fish and admire it. But nowadays, many of our phones are waterproof. It's inexpensive to buy waterproof action cameras or just simple digital cameras that you can use to take photos in water. Or you can lift the fish up, but do it when they're dripping. So get your buddy to get ready with the camera when it's time, lift it out. you should see water dripping off your hands and off that fish. That's what Keep 'em Wet is all about. Those are incredible images, and those are the images that I like. Whenever I see a hero shot where it's an angler hoisting up a fish well away from water, not over water, they do nothing for me. I sort of look away because I want to see a fish near water. That's where they came from, and I think these images are much more beautiful than hero shots. So something to think about, something that you can try and work on. A lot of it's about sharing the right information. I think there's a lot of opportunity for us to engage directly with the tackle manufacturers, with angling celebrities and others to promote best practices. In this case, you can see a rather prominent angler in the bottom, kissing a fish, two fish, being air exposed. I'm not really sure what that's supposed to prove or demonstrate, but guess what? Scientists do it too. In the bottom right-hand corner is a fishery science journal, one of the most prominent ones that's in our field, our discipline. And there's a picture of a smallmouth bass being air exposed, and that fish is not dripping wet. So even as a group of scientists, we've done a poor way promoting those best handling practices. A few years ago, many years ago now, I guess, a couple of my students went through all the guidelines and guidebooks that different state and provincial agencies had produced to share best angling practices. And it turned out that many of them were suggesting and recommending practices that actually were bad for fish. So even our governments who have legal responsibility for trying to protect fisheries are sometimes failing us with the information they're sharing. One of the things that we need to think a lot more about is how to change behaviors and how to improve them. One of the things that we're seeing as being particularly important is what we call sanctioning, where if I'm fishing and I see somebody doing something, that I maybe give them a little nudge. And to be clear, I'm not talking about vigilantism. I'm not talking about shaming. I'm talking about just a helpful suggestion. Hey, do you want me to show you how to, help to remove that fish? Or, hey, do you want to use my pliers so that you can reduce air exposure? I think that that's one of the things that we can do as individual anglers, as stewards of the resource, help to correct some of those poor behaviors, especially among novice anglers. As we wrap things up here, we've been talking a lot about catch and release. And so a lot of people assume that if I study it, I must do it a lot. And certainly I do. But do I release all the fish I catch? No. And there's a picture of me with a nice little jack that I've caught that I'm going to enjoy for dinner. And I think that's one of the things we need to do too. Encourage and remind people that it's okay to harvest fish. There should be no odium with keeping a few fish for dinner. That's one of the great things about recreational fishing. It's being able to not just enjoy the catch, but also to be able to enjoy a good meal on occasion. Just do it responsibly. Obviously, follow the regulations, and try to put back the biggest fish, the fish that are the key spawners in a population. So some take-home points. There's no silver magic bullet for catching fish. It's called fishing and not catching. That's something I have to remind my kids of constantly. Spending time on or in the water is your best approach to learn more about how to become a better angler. For fish that you're going to release, the fate of those fish is largely in your hands. So take that as a responsibility and learn what you can to ensure that those fish have the best chance of survival. Adopt best practices like the 3 simple keep 'em wet principles that I described, and share those best practices with others. Be a steward of your resource. And then selective harvest makes great sense. If you've got a fish that's deeply hooked and not doing well, and it's legal to harvest, maybe that's the fish that you should bring home at the end of the day, not the first fish you catch or the last fish you catch. So I strongly believe in selective harvest and hope that next time you're fishing, the science that I've shared here today will help you become a better angler, will help you be able to release those fish that you intend to release in a bigger way, and also guilt-free, enjoy a meal on occasion, and engage in selective harvest, which I think just makes good sense. With that, normally we'd have a question period, and usually there's things that get asked that are fascinating. We have great discussions. Obviously, we can't do that in real time. I encourage you to post questions here to the Queen's Biology Station Facebook page. I'll keep an eye on it and try and answer them over the next little while. Feel free to check out our website, as well as drop me an email if you have any questions, concerns, ideas. We really depend on anglers to guide us in the science we should do. We're trying to be relevant to you and give you the information you need. So if you've got any ideas, don't hesitate to share them. And I'd also like to end by thanking Queen's Biology Station. It is the absolute perfect place to do this kind of research, and we've learned so much about catch and release science thanks to the unique facilities and unique resources and supports provided by Queen's Biology Station. With that, thank you for your support, and I wish everybody a very safe and enjoyable fishing season. Take care.